All right, this is number 5 on log 9. The yearly cost for residents to attend a state university has been increased from 5,200 to 9,000 in the last 5 years. To the nearest tenth of a percent, what has the average annual percent of increase? It says this is a tough one, be tough. I think that's a little misleading because I don't really think it's as difficult as that little saying might lead you to think. So they're talking about the yearly cost. So first of all, your equation is going to be y equals a 1 plus r raised to the t, because that's going to be your yearly cost. And it says that it started at 5,200, so that a value would be 5,200. It ends at 9,000, so 9,000 is your y value, and then time is 5 years. So all you really have to do is plug all of those values in. So here's your equation. This is your 5,000, your 9,000, and then your time is 5 years. So if I plug that in, I get 9,000 equals 5,200, 1 plus r raised to the t. Whoops, t is 5 years, sorry. All right, so now my variable is here in my parentheses, so I have to get this expression right here by itself. So I'm going to take the 9,000 and divide it by the 5,200 equals 1 plus r to the 5. And I suppose I can take that 9,000 divided by 5,200 and simplify the fraction, and I'll get 45 over 26. It doesn't really matter. You didn't really have to simplify it right then. You could have simplified it later. It just makes writing a little bit easier. All right, so now this kind of goes back to our last chapter where we have something raised to the 5th power. Well, to kind of undo that, I have to take the 5th root of both sides. So now I'm going to get the 5th root of 45 over 26 equals 1 plus r, because if I take the 5th root of something that's raised to the 5th power, it's as if those cancel each other out. And then I just have to subtract the 1, and I'll have an expression equaling to r. So I'm just going to go and put this in my calculator. The easiest way to put this in my calculator is to go 45 divided by 26 and then raise that to the 1/5 power, because that would be the same thing as taking the 5th root. So if you do that, you're going to go 45 divided by 26, raise that to the 1/5 power, and I get 1.12. So my rate is 1.12. All right. Now let's talk about, I need a little more light here. Hold on. There we go. Let's talk about graphing a little bit and what I might expect on the quiz on graphing. So let's say you have something like y equals the log base 2 of x plus 3 minus 1. All right. So first thing you want to do is figure out what your shift is. So my shift, if you know, is going to be -3, -1. So 1, 2, 3, -1. And I'm going to put an X there because that's not actually part of my graph, but it is going to be like my starting point. It's as if I took my 0, 0 and moved it over here. Because this is a log equation, I know my asymptote is going to be vertical. And so the equation of my asymptote would be x equals -3. Can't really see that down there, but x equals -3. All right. Now that I've taken care of my shift, my parent function, which I guess I'll write up here, is really y equals the log 2 of x. So if I'm going to do an xy table for my parent function, I'm going to pick convenient values of x. And since this is a log, convenient values would be 1. It's base 2, so I'm going to do multiples of 2. So 2, 4. I'm going to do 1/2 and 1/4. So if I plug those in, I usually start at the middle of my table. The log 2 of 1 gives me 0. The log 2 of 2 will give me 1. The log 2 of 4 will give me 2. The log 2 of 1/2 will give me -1. and the log 2 of 1/4 will give me -2. So this here now is the table for the parent function. I'm going to take these values and I'm going to plot them from this point as if this point was my 0, 0. So I'm going to go over 1, 0. I'm going to go over 2, up 1. I'm going over 4, 1, 2, 3, 4, up 2. I'm going to go over a half, down 1, over a quarter, down 2. So you can see your graph is going to come like this, and it's just going to hug your asymptote. And that's what the work I'm going to want to see on the quiz.